Your number is ending in 155. Go ahead and ask your question. Hello? Okay, do you have yeah, go ahead and introduce yourself and ask your question.
Oh, okay. My name is Robert. Eric, I know that I was following some of your videos, some of your information regarding your study of the sun. Is it possible, I mean, let me ask this question, maybe kind of precursor. Were you able to confirm the distance of the sun from the center surface of the Earth and the moon? And the second part is, could it be measured based on the atmospheric layer temperature?
Yeah, I have no way to measure the distance, or basically it was the ionosphere that I was using as my indication. So I had a very sophisticated RCA dual diversity shortwave receiving system and two antennas that were pointed at right angles to each other. So I had this thing that I called the Earth stereo, where you could hear the echoes and what have you of the signals around the Earth. And then that allowed me to study and how the sun was impacting it in the magnetic field. And then at that time, I was receiving a considerable quantity of material from what's called the Space Environmental Services Center. Of course, none of this information is available anymore, but I had detailed records of the velocity of the solar wind, the direction, intensity of the interplanetary magnetic field, visual imagery of the sun in several different wavelengths and dimensionalities. I received, every month I got about a 150-page book with all this information, and then there was a newsletter that came out every 5 days with a hand-drawn diagram of the sun showing the movement of the sunspots and what have you. So this was a 4-year study I did at Sonoma State University during an interval in which all the planets lined up. That was October 13th to 15th of 1980. And the equipment provided to me by RCA and the facilities made available to me at Sonoma State College. The objective was to verify the original experiments of the Radio Corporation of America that planetary configurations have a direct impact on HF radio propagation and the ionosphere and a number of other environmental factors. In fact, there was a popular book written on this subject called The Jupiter Effect.
Yeah, I got that book. I remember you mentioned it.
Yeah.
Well, the thing, what I wanted to refer to is this. I found 2 separate measurements that were taken. One was by NASA, the other one was by the Chinese Academy of Space Technology. They judged the distance from low Earth orbit to about 2,000 kilometers. And then I collected several pieces of information to kind of get a median number of what the temperatures were in the thermosphere, which is when you get to the middle, you're at pretty much the high end, and the temperature is consistent in excess of like 1,500 degrees Celsius. But the data that's out there on the surface temperature of the sun is in excess of 5,800 degrees Kelvin. So I, fiddled around with some mathematics to take the vertical distance from the center surface of the Earth, 90 degrees, based on low Earth orbit, factored in what the average distance would be of where the sun possibly could be. Because NASA's saying that the moon, the surface temperatures are minus 253 to 256 degrees Fahrenheit to plus 256 degrees Fahrenheit. Now that's a pretty consistent temperature. Well, those temperatures are consistent at around 200 to 300 kilometers above the surface of the Earth. When you take the sun at 5,800 degrees Kelvin, that's in excess of maybe 650, 700, maybe 800 kilometers, which to me, if that's the consistent surface temperature of the sun, then it can't be what they say it is at 93 million miles. And that's how I ended up coming up with some sort of more, I'm not going to say definitive, but it's a better average than what is being put out there in science. Because they're talking about launching probes to go to the sun. But when you're looking at videos and you're looking at data on the Federation Aeronautique Internationale for highest altitudes and distances, and I looked at video and I compared videos of every space shuttle launch, every time I look at the telemetry data, I see the space shuttle disconnect from the main fuel tank at 350,000 feet above the surface of the Earth. Now, I want to know how it is, based on what we know about acceleration and velocity and speed, how it is something can travel at 16,000 miles an hour, disconnect from this large fuel tank, cut its engines off at 350,000 feet, and then have to travel another 130 to 140 miles to something they claim is 250 miles away, in geosync orbit, traveling at 17,000 miles an hour, the size of a football field, 100 yards long, 50 yards wide. That just doesn't make any sense to me, because there's atmosphere there. And if the ISS is losing 1.2 miles every orbit, and so with the space shuttle, once it got at its velocity, and it has to gain another 1,000 miles to catch up. It's just, to me, the way things are looking with regard to the moon, the surface temperature of the moon, it has to be, for me, when I did the math, I got a mean distance of somewhere between 62.5 to 68 miles. 68 miles. And I've also been doing research on Dr. James Van Allen. He claimed to have launched a 3-foot rocket on a balloon from the University of Iowa in 1957. And somehow this rocket got to 2,400 kilometers from the surface of the Earth in Iowa, from the football field, to measure the Van Allen belts. And this is all in his papers. So at that time, in 1950s, the U.S. Naval Research Laboratory, they drafted a report doing upper atmospheric testing rockets, and nothing got beyond 73 miles. So how can he go to 2,400 kilometers with a 3-foot rocket? See, a lot of this, you're doing a lot of your research, comparing it to a lot of things Tesla's doing. I mean, everything that you're saying is fantastic. But the problem I'm having is that the information that's put out there in the mainstream academia, it's not consistent. You got the Chinese saying that low Earth orbit is 2,000 kilometers, but you got NASA saying that low Earth orbit is at somewhere around 800 kilometers, 100 kilometers. They can't even agree with each other.
Yeah, it's kind of like we're not really being provided with accurate information, and or their measurement concepts or what they don't really know what they're trying to measure. A lot of this stuff, like the sun, we have no idea what dimensionalities or coordinate systems exist inside the sun, and we'll never know. The hollow sun concept presents itself in that situation, and then when you get in outer space, you can't see any direct light. It's only reflected light. So then what is light? The velocity of light seems to be questionable. All my Steinmetz books say the velocity of light is 188,000 miles per second. But we're told that it's 100. It's less than 184 or whatever. I can't remember now because I always use metric. But so
would you agree that the sun is still within our atmosphere?
What's that now?
Would you agree then that the sun can't be in free space and it's somewhere within the exosphere and it's reflecting off of the rest of the gases and whatever particles that are inside our atmosphere, and it's not in free space?
Yeah, well, apparently the primary emission from the suns and the stars is not light. It's something else. So that means that the velocity of light would have no meaning because it's not light. It's only light when it comes in contact with physical matter, and then that's kind of how it presents itself to us anyway, because, you know, you can have a light bulb hanging on the ceiling and it's lighting up the page on the table, but it's not lighting up anything in between. So there's all these inconsistencies, and then if you want to get a perspective on all this, I really recommend going back and reading E.T. Whitaker's book on the history of the theories of ether and electricity, and you'll find out that the science of optics was a very convoluted thing during this scientific age, if you want to call it such, in the 1900s. And there's so many inconsistencies and experiments that didn't correspond to equations and concepts. It seems like basically what happened is after about late 1890s into 1900 that everything actually started going backwards.
Okay.
And so now,
I would agree with that.
now it's just gibberish. You know, it's like we were on the internet the other day, me and one other guy that's part of my organization here, searching for grants. So he was on the internet and I was on the telephone talking to him. And, you know, these various people that do this earthquake and geological research and all that is the language is so wordy and beating around the bush and so overly complicated and abstract and symbolic that it has no connection to reality whatsoever.
That's exactly what Nikola Tesla said. That's exactly what Tesla said. Scientists fiddle around equation after equation, trying to develop some sort of construct that has no relation to reality at all.
No. The thing is here, you know, I mean, I'm a professor on the subject, and my whole life since 6 years old has been devoted to electrical transmission and experimentation and research into electrical transmission, whether it be radio or wireline or whatever. And by the time that I graduated from high school, I was a licensed radio engineer and was a competent electrical engineer, and felt this confidence that, it's all so explainable, you know, and all you have to do is just go run back to Maxwell's equations and you'll find an answer. But that's not true at all. Those things are just projections and shadows of what's really going on. And then in putting this presentation together, and in my most recent studies of the transmission theory, is probably one of the high priests of transmission theory and network theory is a man by the name of Ernst Gilliman. And he really brought the thing to, how would you say, kind of like a level of conclusion and understanding and unification. And in his introductory chapter called The Engineering Solution to the Long Line Problem, he points out that there are all these modes of electrical propagation in the boundary between the conductor and the dielectric that have just simply been left out. And then he shows further that the differential equations that we all parrot and that all transmission engineering is based on, second-order differential equations, are only two terms of an infinite series. So Tesla worked strictly by experiment at a time in which everybody was experimenting, and it was all very interactive. You can't say that Tesla discovered this or Thomson discovered that or whatever. These people all worked very close together and influenced each other. And in the course of these experiments, the one thing that set Tesla ahead of everybody is Tesla was an electrical engineer and the rest of them were academians. And because Tesla was an electrical engineer, he could perfect the apparatus far, far beyond what any of these university professors could do, because they were still fooling around with stuff that Faraday cooked up. And so they couldn't make the discoveries that Tesla made. So Tesla was using this type of electricity called impulse current, which is basically the mirror image of direct current. abrupt transients. It's not oscillatory. There's no sine waves. It's just it's there and then it vanishes. And then when you make reference to Ernst Gilliman's writings about these surface waves and the radio work of Reginald Fessenden, who was surface waves, and the radio work of Massey, who was broadcasting or transmitting through the magnetic lines of force themselves as a medium, like wires, Tesla, through his experiments and the waveforms he was using, quite possibly discovered modes of electrical transmission that are just completely neglected. You can't say, oh, well, Tesla was just, it was just radio waves, or it was just electrostatic fields, or it was just this or just that, and we can go, with Ohm's law and geometry and all these things, and fit everything that Tesla did in a strange way, but fit it into conventional understanding, but that might not be the case. You see what I'm getting at?
Yeah. Eric, I want to, because you deal with a lot of signal propagation, and I wanted to touch base with you on this because I had a conversation with the head of cardiology at Johns Hopkins. This was quite some time ago. I'm working on a project. I had been working in the Navy for quite some time, and I was an anesthesia tech working with the anesthesia cardiologist. And my research for the past, I'd say, 10 years has involved capturing a specific neurocardiac signature and identifying the signature patterns of the sensory neurites in the human heart. And what I found out when I started diving into electromagnetism is that the heart emits its own electromagnetic field. That field becomes stronger in colder temperatures. Which means that for me to conduct any sort of field testing, I'd have a higher rate of success, conducting this experiment in colder temperatures. Now, I also went into the realm of, looking into advanced Wi-Fi and turning current Wi-Fi into a biomedical measurement and signature intelligence device, whereby instead of it picking up radio frequency signals and transmitting them, it would actually pick up the specific signature that every single human heart gave off from the SA node. The SA node is the first electrical spark actually functioning within 3 to 4 weeks of conception. It's the first signal present in the human body. The heart hasn't formed, the brain hasn't formed, and none of the other neurological systems have formed. You just have this small piece of fibrous neurological tissue firing on an oscillator, on a echograph, creating the sound that you would hear when a mother's pregnant 3 or 4 weeks. So my thought was this: it took me into another area with regard to the resonance of the sun and what that frequency was. And a lot of the research I've been finding out is that the resonance, the sound and signature of the sun is nearly identical to the same electromagnetic field signature of the human heart. And then it took me into another area regarding the electromagnetic field supposedly around the Earth. And being in the Navy, I discovered something interesting looking at the National Oceanic website, the USGS, is that the further you sail outward, away, out from large land masses, the colder it gets. The colder the air temperature and the water temperatures get. So could it be possible, the further you get out from land masses, in every which direction from the center surface of the Earth, out in the waters, we know that electromagnetic strengths and fields increase in colder temperatures and decrease during warmer temperatures. So what could be providing this sort of cryogenic environment out away from the landmasses where the temperature gets colder? And does the landmass and the gravitational anomalies on land have anything to do with stabilizing the inward temperatures and creating sort of a thermal equilibrium environment layer between the surface centers, and you have a median layer between the outer layer, which is much colder, but no one really knows how cold it can actually get because no one's ever ventured out that far. Does that make any sense? Because sometimes I get out in these things where everything starts to branch out in all these different directions, but I know for a fact when I've seen, and I've been in the observatory deck doing open heart surgeries, they put the heart in a cryogenic environment. They pour saline inside the chest that's been frozen, that's been dropped down to a particular temperature to literally slow down all of the activity in the human heart. And literally, when they are finished what they're doing, I've seen cardiac surgeons just basically flick the heart like they're trying to test for the ripeness of a watermelon or a cantaloupe, and it immediately starts with no paddles, no electrical, jump starter charge. Some patients require electrical jump starter charge, but I found out that the SA node could literally, the entire electrical activity of the heart could be restarted with a 9-volt battery. A 9-volt battery. You don't require 100, 200, 300 joules of electricity. You can get it started with a 9-volt battery.
Yeah, well, that makes.
I just wanted to hear. I just wanted to hear what
the heart is operating on anyway. So, they hit the thing with a half an amp of electric current. It doesn't sound necessary. That 9-volt battery, in a conductive environment like that, actually puts out a rather substantial current. Not surprising.
Yeah, exactly.
Restarts the heart. Probably even a smaller quantity of electric charge would do it. It'd be interesting in the experiment to see what the minimum electric charge is. Otherwise, what you're talking about is kind of outside of my field, so I don't know exactly what to say, but it's quite evident that things are a lot more complex than we're led to believe, and to use the term electromagnetism is not really correct anymore, because electromagnetism is just one very isolated coordinate and dimensional reality, and there are so many different fields. You can turn to the work of Wilhelm Reich for that, and his orgone, and the electrostatic researches of Nikola Tesla, and the stuff that Ernst Gilliman talks about, and whatever, and electromagnetism.
You say it's electrostatic. It's electrostatic, not electromagnetic.
Yeah, Tesla's technology was all electrostatic. Electrostatic's not really the right word. Steinmetz sought other terms, and he called it dielectric field. But there's a complication with that because the dielectric supports both magnetic and electrostatic induction. So to come up with a language to describe this stuff can be rather difficult. That's one of the immense difficulties I have in writing my books and presentations, is to keep a consistent notation, because particularly with the Versor algebra book, because the electromotive force E has so many different configurations that it's very difficult to come up with any kind of sensible arrangement that doesn't have such a clutter of subscripts that you can't visualize it anymore. So
yeah.
Then another complication, like in the transmission books I'm writing, is the word voltage has no meaning. Current does, but the word voltage has no meaning. And that's something that's not understood, is the term voltage.
It's interesting to hear.
Go ahead.
It's interesting to hear that from an electrical engineer. I said that to a professor who was teaching a physics course I was taking, and it pissed him off for me to
physics is a denial of electricity. So physics fancies itself as having the absolute knowledge of the eternal and infinite universe, and all it is a big masturbation process. There is no science of electricity anymore. It died. All that died when Einstein came into being. Is electricity was basically pronounced dead. And if you try to get funding in any of these areas, like I'm working on with, geological, or in your case, life sciences, or any of that type of stuff, and you try to equate what's going on to an electrical situation, you're the bad guy. You're not supposed to. There is no electricity. Everything is thermodynamic and mechanical. And so, situation, everyone parents voltage. You can go around and ask 100 people, some of who are supposed to know and some who are not supposed or wouldn't know what voltage is, and everybody will give you a different answer because voltage is just it's a dimensional construct. It's a bottle to put, to put something in. So you either have electrostatic potential or you have electromotive force. And electrostatic potential and electromotive force are two very, very, very different things. And it's the same thing with current. You either have conduction current or you have displacement current. And again, those are two very, very different things. And in the book that was originally called Lone Pine Writings, I made a very forcible attempt to clarify that issue and to come up with the proper notation that separates these four terms, because electricity is always a fourth-order relationship. It's not a second-order relationship. It's a fourth-order relationship. And to express it in a second-order relationship is just to look at the shadow of it. And unfortunately, the physicists, in their ignorance of the subject, have just petrified everything. I struggled for I don't know how many years to answer a very simple question: is what ratio of electrostatic potential to conduction current in a two-wire transmission line will cause the magnetic force, which is pushing the wires out, and the dielectric force, which is pulling the wires in, to be equal, and then there's no net force on the wires. And I struggled with physics books on that, and the result was I threw them in the garbage.
Eric, you got me thinking really deep just now. I want to ask you this, and I know that this is crazy, because everybody, and Erica, out of anybody, there are people out there trying to create perpetual energy systems, okay? And you just got me thinking about something that was shared with me by an MIT professor, and he sent me an equation. He sent me Planck's equation on black body radiation. And this is my thought with regard to electricity. If you have an electrical current flowing through a cable, which is encompassed of several different other wires, and you're able to not only get that energy and that power from that current being generated, but you're also storing the black body radiation that's being emitted from that cable and having it stored in another system inside some sort of device, whereby when the electrical current is cut off or extended, you now switch to the black body radiation that's been stored to use for backup energy. And I'm not sure I listened to a lot of your videos, read a lot of your information. I'm not sure if you actually mentioned black body radiation before, but this is something that was introduced to me a few years ago, and I'm still studying it. And it just became really interesting because I had been working on this technological capability with Wi-Fi, and I was missing something in a lot of the math and the algorithms that I was putting together. And someone said to me, hey, you might want to look at this. And it was this MIT professor. And it blew my mind, because when I started looking at the math, I'm like, wait a minute, everything emits some sort of black body radiation. Even a spoon that you just touched with your own hand and placed on a table, with the right calibrations on a thermal imaging camera, you'd be able to pick up the level of black body radiation that spoon is actually emitting at that particular moment when you let it go and put it on the table. And I got the same idea when I started looking into, we started discussing, in the classroom, how you could literally become more energy efficient by using the energy that was being created to produce, to capitalize on a secondary form of energy that was being emitted by the creation of the original source, which was black body radiation. Just wanted to hear what you had to say on that.
Oh, it's kind of a little bit out of my understanding. So for me, black body radiation is something that I have to deal with in microwave antennas and typically any kind of outer space communications. But it sounds kind of sounds like what's going on. The black body radiation, from what you might be saying here, is always being emitted, even though it can't be accounted for by any particular thermodynamic input that was stored, but then is emitting the radiation. Now, the thing with currents and cables and all that is a current's just a shadow of a magnetic field of induction. So a current comes about by magnetism being basically consumed inside the conductor. So I put together, I deciphered a lot of J.J. Thomson's work on that, and I put that out on the internet. It's presently out in what we refer to right now as notebook number 4, because none of this is being described or published, but the Thomson theory of how conduction current comes about and the relationship with magnetism. Then Thomson asserts that magnetism also is a secondary, and that it's actually what he called the Faraday tubes, or the ether lines of force, which are basically electrostatic or dielectric in nature, and showed that everything basically evolves out of these tubes of electric induction, and the current flow in the conductor is an end of the line situation. Years ago I used to give the analogy is current is the footprints in the snow of the invisible man.
I like that.
Invisible man, you can see his footprints, but you can't see him. So how do you see, or we have to use mathematics and special test devices and what have you. Simple compass actually works quite well for a lot of stuff.
Yeah.
To measure these things, but all this is so much more involved than this modernistic interpretation. That's what inspired Thomson and Tesla and Heaviside and all these people. Is Tesla came right out and said that electricity is Aladdin's lamp, and that was the premise in my last presentation. Is the ether can't be pinpointed to some specific material or configuration. The ether is what you ask the ether to be.
Exactly. It was what Einstein and Planck said about quantum of consciousness. When they all agreed this is what the outcome would be, it would be. But if there was one person who doubted it, it would not be the outcome they were expecting. It is what it is. That's that coin of phrase. Last question there. Do you believe that there's like a dipole, a north and south pole, or is there one single pole, a magnetic monopole that just shifts or rotates?
With reference to, you mean the Earth's magnetic field?
The Earth's magnetic field. Do you think that there's two separate poles or just one single magnetic monopole that just shifts every now and then?
Well, I pretty much have it visualized as a pair of poles because magnetism is a closed loop phenomenon. So a magnetic monopole is kind of a difficulty, even though the Tesla transformer kind of simulates such a condition because you can have a current at one end with no return line, and you can have a potential at the other end without any reference to ground. So that makes one end a magnetic monopole and one end dielectric monopole. So I suppose if you were to extend that to the Earth, you could have a pair of those. So then you would have to have four poles. So the Earth has a very predominant electrostatic field. In fact, there's probably more energy stored in the electrostatic field of the Earth than there is the magnetic field of the Earth, except right around the poles. Which is if you have any receiving equipment, like these long line antennas I built, where you can hear every lightning strike on the planet. I mean, this stuff's in a constant roar. That's a lot of dynamics. That's a lot of 50 microsecond, 50,000 amp, 1 million volt discharges, and they're at a constant rate. And then there's these auroral electrojets. So around the poles, there's a current flow of about 25,000 amps in the upper atmosphere in a big ring around the poles, which basically is a giant inductance coil. So in all probability, that's where the Earth's magnetic field originates from. This concept of some bar magnet inside of the Earth is pure garbage. I mean, first. So
do you think that
there's what's called the Curie effect, and if you take a piece of iron and you bring it to an incandescent temperature, iron has no more magnetic permeability other than that of the ether itself. So if this theory of the inside of the Earth has all this molten stuff and the temperature's all high and all that, which I don't believe anyway, but you can't have a bar magnet inside the Earth because it's too hot. None of it makes any sense. The Earth's magnetic field is generated by the electric induction from the sun, just like the light on the Earth and the heat on the Earth is generated by the electric induction of the sun. And what that electric induction from the sun is becomes completely indeterminate when you get into a mass-free environment like outer space. And then if there's no light and no electromagnetism directly, then this whole notion that it takes, 10,000 years for the light to reach us from some distant part of the universe doesn't make any sense. So it's only when it gets converted to electromagnetism does that velocity present itself. And then the velocity of light is just an abstract anyway. All it is the square root of proportionality between the total amount of magnetic induction and the total amount of dielectric induction in any given point of space. And it's not a velocity at all.
It's just static.
It's just a dimensional relationship. It just happens to be. I hit on this real heavy in the presentation before last. Is how did this understanding of Maxwell and the velocity of light come about? And basically, it's just a proportionality factor that exists between the magnetic field and the dielectric field that gives you the dimensions of 1 over velocity squared, which happens to numerically and dimensionally equal 1 over the speed of light squared, but it's not the speed of light. And the thing I hope to point out in this next presentation is when you start doing transmission studies, you can get yourself in real deep trouble in your calculations, assuming that the propagation velocity is that of light in that particular medium, because the lower you go in frequency and you start getting close to DC, the propagation velocity goes down and down and down. So if you have a 25-cycle power system, like for a major electrical railway, and you're using conductors that there's no skin effect because the frequency is so low, and that the full conduction is taking part in the metal, the velocity of propagation is only about 10% that of light. And when you get down to direct current, there's no propagation velocity at all. So there's basically no theoretical understanding or justification for how direct current can even exist.
Wow.
There's all these open-end situations that just simply aren't addressed anymore. when, you know, in the days of Steinmetz and Kennelly and Heaviside and all these people, you know, these things were still being considered, but now it's just all gone. I don't even think I would go so far to say that electrical engineering itself doesn't even exist anymore. The stuff that I see going on in the power system, you know, for somebody that was spoon-fed on this since the age of 6, to me is absolutely appalling. It's almost pornographic.
Yeah, you know, I'm not an electrical engineer, and I know very little about electricity because for the past half a decade I've been dabbling in Wi-Fi and been fascinated with that, and got access to some data that I had to sign a non-disclosure for with Intel. I wanted to understand how their advanced Wi-Fi adapter worked. You know, what did they do to, you know, change the specific, you know, power structure and transmission speed. And in the process of doing that, I ended up downloading MATLAB Signal Processing Toolbox, started to fool around with the adapter to literally overclock the capacity to the point where it sapped my battery in less than 30 minutes as soon as I plugged it in. But the range of the signal that I actually transmitted and received, because I was conducting, you know, just a little small test to see how many different biophysics signatures I could capture from, say, maybe 50 yards. And I was looking out the window of you know, my home office, and every person who walked in front of the window, I was picking up signatures. I mean, there was nothing else passing in front of the window, any dogs, cats, or animals, or birds, or anything like that. But I had already programmed in knowing exactly what that human signature would look like, and I just wanted to see what it would do. And there was a group in the U.S. called Incutel. They actually drafted a paper behind a research paper I drafted on the university level for IT security measures, countermeasures, and it's titled Exploiting Physiological Intelligence. And it's basically the same concept. When you turn on your computer and you look at the Wi-Fi icon on there, you'll get a list of every single Wi-Fi connection that's within range of your own system. My system is the same exact way, but instead of seeing computers that are plugged in, you see people. You see the physiological intelligence signatures of people. You click on one of those, and you'll be able to read the physiological electrical intelligence of that particular individual on a biophysics level. I mean, it's just interesting. I mean, I'm having to go into all these different directions, and I just can't stay. If I were just to focus on cellular biophysics, that wouldn't be enough. I'd still be missing something. And, you know, I'm starting to look around me to see that, you know, things that are happening every day on the so-called physical level are giving me answers and solutions to some of the, not problems, but ingredients that I need to continue to add to this entire system in of itself, because there are certain people, what I'm finding out, that are actually developing negative health effects to the exposure of Wi-Fi.
Well, yeah,
So,
I did research on that years ago, and that stuff is not good. So
yeah, but here's the thing.
It started with basically in my childhood experience with Bell Telephone, I was taught, you know, safety procedures and standards of exposures to those particular wavelengths, which range between like 30 centimeters and 10 centimeters, and you know, accordingly protected myself from exposures to this to what today would be considered a fanatical degree, because all those safety standards have been dumped in the toilet bowl. So there was a point in history, I think it was around 1969, that American embassy, I think it was in Moscow or something, it had been determined that there was a 400 megacycle carrier wave that was being broadcast through there. It wasn't particularly powerful. The purpose of it is what you do is you listen to the echoes that come back, and the vibrations of physical objects in the room modulate the radio waves, and you turn it through a phase comparator, and then you can hear what people are saying inside the building. Today they use lasers.
That's what you're talking about.
So at any rate, everybody was getting sick, or there was something that made this a famous story in its time. So the woman that was running the science department in my high school knew that I had a Bell System TD2 microwave system in my laboratory in my parents' garage. So she showed me an issue of a magazine that was popular amongst science teachers and what have you. I think it was titled Science or something like that. And they had discussed this Soviet thing, and they had done some experiments with milliwatt levels of these 30 to 10 centimeter wavelengths. In this case, it was the frequency I was using was 4,000 megacycles. And she wanted me to duplicate the experiment, to bring this stuff to school and set up a laboratory away from the rest of the students. So, the principal was all concerned about radiation and stuff, so they set me up with a laboratory. And sure enough, no more than 10 or 15 milliwatts of exposure of those frequencies to radish seeds produced radical changes in germination and growth patterns. For only 15 minutes of exposure, and now human exposure to these particular wavelengths is orders of magnitude greater than that. Particularly, your silly phone. So you're holding this thing right next to you. I encouraged some people once to do an experiment, take radish seeds, and back when these things still had external antenna on them, and tape them onto the antenna, and then motor mouth on the phone for a couple of hours, and then take the seeds and plant them side by side with the control seeds that are kept in some kind of thermal environment, which would be the same temperature. That's what we did. And see what level of mutation this stuff causes. But this Wi-Fi thing now has just created a complete saturation of centimeter wavelength interference. And, it's interesting.
That's interesting.
Sonar to examine the body, which is interesting. That really doesn't have much to do with the digital end of it, because you're dealing with radio waves themselves and not the modulation, but maybe the spectra of the digital. I'd have to kind of see what it is that you were.
Yeah. That's something I'd love to share with you at a later time privately. Because I was speaking with an associate this past weekend. The sun gives off supposedly electromagnetic waves, similar to what it's Wi-Fi does it artificially, of course. But I found a National Institute of Health study, that broke down the effects of skin cancer in race and ethnicity, and the results and findings were incredible, because it allowed me to do some more research to find out if the National Institute of Health did research on electromagnetic wave propagation and how it might have affected race as well. So I took the two studies and I found out that electromagnetic waves from cell phones and other types of electronic devices have a negative effect on people of low melanin count or fair skin, whereas people with a very high melanin count and dark skin, African, black people, they can absorb the UV radiation, electromagnetic wave radiation, and it doesn't have any kind of ill or adverse effects to them physically at all. And it has nothing to do with the fact that they can't afford to have computers all over their house and cell phones and so on and so forth. But the study involved, the same equal group of, different ethnicities and races. And they all use the same devices at the same level. And there was literally less than 1% adverse effect on the higher melon count of people versus fair skin and Caucasian. So it dawned.
I have a complication, when I do outside, work and what have you, and if you use plastic wire ties that are white, they have no life whatsoever. The altitude or here is just, the sunlight just destroys them. But if you use black wire ties, they're not affected, which makes sense because the black basically just kind of short circuits the whole thing out. There's no depth of penetration for the radiation to get in, where if they're, kind of quasi-clear or white, the radiation can get right in and then destroy the molecular structure of plastic.
I thought that was really interesting where, blacks can absorb UV radiation. It makes their bones more dense and stronger, and it has the exact opposite effect.
I wouldn't say that they're absorbing it, and I would say more that they're shorting it out. They can't properly.
Well, on a physiological and anatomic comparative level, blacks do have a higher bone density and body mass density than their Caucasian counterpart. The medical research, tries to explain why this is, but when you throw the sun into it, and we all grew up saying, oh, you need to have some sunlight, it's rich with vitamin D. Well, that's the same thing, they're claiming, hey, drink your milk because milk will help your bones grow stronger. We all were told this when we were kids, but you get it naturally from the sun. I mean, for example, when my son was born, the first 6 hours of his life, the first thing the nurse told me, hey, go walk outside the room, the sun is out, just stand up against the window, let the sun shine on him so he can get some color, and absorb some of these vitamins, and this was something I had already known, because I worked in a hospital on a pediatric ward, but it gave me that time to think, like, wow, I need to start doing some more research into, what I'm doing on the advanced technical level, because now, I've got to be more cognizant of, okay, what's the environment doing? How is that going to affect what I'm going to develop on the hardware, software, technical level with regard to signal transmission and receipt? And, I know there's probably other people who want to talk and ask you a bunch of questions. I'd love to share emails with you. If you don't do emails,
no, I don't have to email, but you can always write me at my Lone Pine address.
Yeah, I have that address, and I'll write to you, and then we can have a phone conversation. I want to share with you the algorithm because I had to have a German test and measurement company develop, custom engineer one of their advanced oscillators, where I needed them to remove a piece of hardware that would allow me to capture this signal on the measurement signature at a level. And they got really interested in why I wanted to do that and said, hey, we'd like to talk to you about this. What are you working on? And I'm like, for right now, can you do it? Just let me know if you can do it. So I'm heading into the final stages of putting the prototype out there. And once I have that, I'd love to share it with you so you can kind of reverse engineer it and tell me what you think and how it could be made better or how it could be made multi-purpose in several different areas. Because NASA JPL out in Pasadena became interested in the algorithm, shared it with their signals lab, and the first question out of their mouth was, where did you get this? What are you working on? And I'm like, nothing. Did you validate it? Yeah, we did validate it. This is incredible. What, you want to talk to us? No, I don't want to talk to you. Thank you very much. And that was it. Never spoke to them again. But they ended up creating something similar to what I'm working on. And you can find it on the internet. It's called the Finder. JPL. It's called the Finder. Now, what they developed is about a carry-on size, suitcase size device, and it's got it's a hot mess. What I will put out in the field will be the size of a credit card you can plug into a laptop. And actually, it'll be the size of like the USB key from your wireless mouse you can plug into a laptop. That's how big it'll be. That's how big it'll be. What they developed is just a box of garbage. But they developed it based on the paper that was shared with them on the university level. So, Eric, I want to thank you very much. I mean, I've been watching your videos, listening to you a long time, and I couldn't believe I was going to have this opportunity to actually ask you a question, and it's an honor. I'm going to continue to follow you. Stay healthy, stay strong, and I look forward to, speaking with you further and exchanging brain synapses and neurons. Thank you very much.
Well, thank you. It sounds very interesting.
Take care, sir.
Eric? Oh, I can keep going all day.